Hi 111. In this video we're going to talk about the beginning of section 2.5, and in section 2.5 we're going to be talking about what are called transformations. And transformations is a fancy way of talking about techniques that we can use to change the shape or location of a graph in the xy plane. Okay, so say we start out with the graph of some kind of a function. These techniques we're going to talk about in this video and also in the video for next time are ways that we can change its shape, change the shape of the graph slightly. We don't want to significantly change it, but we want to change its shape slightly and maybe move it around in the xy plane. So let's first of all start out with maybe just an example. Let's use our calculator, and I'd like to graph the equation y equals x squared. So let's go ahead and enter that and hit graph. Okay, so here this is our standard looking parabola, right? It passes through the origin. It's opening up like this, right? We say opening up if it, remember, opens towards the positive y values here. What I'd like to do is go back to our y equals menu here, and in y2 I'd like to enter a slightly different form of this graph. So let's enter x squared plus 2. Okay, and I haven't done our key presses here because I'm not going to be using any really different commands or anything like that. We're only going to be in the y equals menu and entering different graphs, if different equations like this, we can see their graphs. Okay, so let's enter x squared plus 2 and let's hit graph and see what happens. There's our original x squared, and here's x squared plus 2. Now it still has that parabola shape, right? But it looks like it's like a little higher or something, right? Yeah, it's like scooted up a little bit. Let's go back to our y equals now, and let's maybe make a new one. How about we, instead of plus 2, let's subtract 2. And let's see what this does. Let's hit graph. Oh, so we had x squared as that middle one, x squared plus 2 is the one that was scooted up, and x squared minus 2 is that one down there, right? And if you look at the little tick marks here, it looks like that x squared was at the origin and x squared plus 2 was what? 1, 2, scooted up 2 marks, and x squared minus 2 was scooted down 2 marks. Well, let's see if that's always the case here. Let's see, let's change those 2's to, how about we change those to 4? So if you just get your cursor on there and hit a 4, and then let's go down to the next one. Get your cursor on top of that 2 and change it to a 4. Okay, so then now we're doing x squared plus 4 and x squared minus 4. Let's hit graph and see what happens. So we've got x squared is first, x squared plus 4, and x squared minus 4. So they all look like parabolas, right? All the same shape. But notice here the x squared is at the origin still, starting out. X squared plus 4 happens what? 1, 2, 3, 4 tick marks up. And x squared minus 4 happens 1, 2, 3, 4 tick marks down. And that's not by accident, right? What we actually have going on here in the y equals menu is a transformation. We've taken the graph of x squared, and by adding or subtracting a real number to it, we've been able to shift it and move it around in the xy plane here. We've been able to shift it up or down. And the reason this graph is moving up and down is because if you look back at the equations here, notice that the difference between y equals x squared and y equals x squared plus 4 says to do the what? You square the input here, right? And then you add 4, right? So you're adding 4 to all of the output values, right? All of the y values, you're adding 4. You're making all the outputs larger, right? And so what this does is modifies all the outputs and changes all the y values, which changing y values is a vertical sort of concern for us, right? The y stuff is vertical here. So changing y values means that the vertical is going to be changed. We're going to move the graph up or down. So let's make an actual summary for that, and your book outlines a definition on page 100, right? So there's a little definition on page 100, but I can summarize it for you here. If we have an equation like this, y equals f of x, right, some kind of a function, okay, if we say take that function and add to it a number, right, where k is a real number, and you know what? I think I'd like to have k be positive also, just to make things easy. Okay. So let's say I add a positive real number right here. Then the new graph is the same shape as f of x, but I've shifted it up k units. Let's see. So then we'll say the new graph is graph of f of x and we say it is shifted up k units, right? So if we've shifted it up k units and we added, say we added 3, then we've shifted it up 3 units, right? Over here in our graphs, we added 4. If you go back to y equals, right? This is the equation x squared, right? The graph of, or the description for x squared here. And I add 4, that's my k right there. So the graph has been shifted up 4 units. Okay, I can do something very similar if I slightly change what is happening here, right? So if I, instead of this addition, if I make this a subtraction, and I'll make this in a marker color here. If I make this a subtraction here, right? Now, instead of being shifted up, my new graph would be shifted down. Okay? And each of these two kinds of shifts, like this shifting up and shifting down, those are called vertical shifts. Okay, so we can say we just defined the two kinds of vertical shifts. Shifts up and shifts down. Okay, so shifts up are achieved by adding a positive number, and shifts down are achieved by subtracting a positive number. Okay, and so that's how we work with those kinds of shifts. Let's see if we could do a different kind of shift. Now we'll spend more time doing these kinds of shifts in class together, okay? But I want to just do an exploration for right now with these kinds of things. So let's try something else. Let's try, instead of just taking and adding 4 and subtracting 4 like this, let's add it in a different place in the equation. Okay, so let's still take that y equals x squared thing that we had before, but now what I'd like to do is I'd like to add and subtract 4 directly to the x before the squaring happens, like this. Notice now that that 4 adds directly to the x before the squaring operation happens, right? And I'd like to do the same thing with subtraction. Okay, so let's enter these two equations now in here in our y equals. Let's clear that second one out and the third, and let's enter each of these. Notice the parentheses, so be careful and make sure you use parentheses as well. Okay, there's the first one, and here's the second one. Again, I'm not using my key presses because I'm not using any fancy buttons other than the parentheses and the numbers and the operations. Okay, so I've got x squared, x plus 4, the quantity squared, and x minus 4, the quantity squared. And I'd like to hit graph and see what happens. So the first one is the x squared, the second one is the x plus 4 squared, and the third one is the x minus 4 squared. Okay, so is this the same kind of change that we saw, the same kind of shifting that we saw in the previous ones where we were adding and subtracting 4 to the output? Right? Notice on this previous page, remember we were adding and subtracting a number to the output, to the x squared, right? On this page we were doing things like this. We had x squared and then we added the 4, right? The order of operations here is different, right? So here what we had was the squaring action acting on the x and then the 4 was added. But now over here the operation is different, right? The addition happens to the x and then the squaring operation happens. So it's significantly different, right? The operations have been reversed. And what kind of a change do we see now in the graphs? It's no longer a vertical shifting, but it's now a horizontal shifting. It's a shifting left and right, yeah? And so let's see if we can figure out which way went which direction, right? Okay, so let's see. Notice that they graphed in order, right? So if we go back to our y equals here, right? y1, y2, and y3, it was the original x squared, then the plus 4, and the minus 4. So let's go to the graph. If you're trying to figure out which one is which, you can always hit trace, and then up here in the left corner of your calculator, it tells you which graph you're on. I'm currently on y1. That's that middle graph of x squared. If you hit up or down, you're going to toggle to one of the other graphs. So let's hit up or down, right? So if I hit down, I go to y2. y2 is which graph? Well, I can't see my cursor, so let's move left or right and see where it is. It's getting more negative. Maybe I should try the other direction. A lot of times this is just trying to figure out where your actual cursor is, right? Oh, there it is. Aha! So y2, it turns out, y2, right, that's this second one right here, right? This is y1, this is y2, and this is our y3 according to our calculator. y2 is this left graph over here, right? That seems a little counterintuitive, right? Because you would think that this plus right here, you would think that that means move positively, right? Which for us on the x-axis, if we're moving along the x-axis, we're thinking. That would think right, right? But looks like that means move left. Let's see, maybe we can confirm that in a second. So in this other one here, let's see. So for this next one, let's see what happens with this one. It looks like, which graph is this? Y3. How do we get to Y3? So let's hit down again. Now it says I'm on Y3, right? So let's move left and right here. Let's see, how do I get over? Notice my X values are small. I haven't yet gotten over here yet, right? So I need to keep going. Oh, there's my cursor. So that is in fact Y3 right there. So again, this is sort of thinking a little, this is not according to our intuition here, right? This negative you would think would have meant move left, right? But it actually turns out that it means move right. Interesting. So it looks like maybe we can make a hypothesis, if we want to use a fancy word, right? That if we sort of do this addition or subtraction directly to the x, right, before we let any other operations happen here, that we're going to be doing some sort of a transformation, a shift, and it's going to be a left to right shift, but it might be a little bit backwards from what we were thinking. So let's see if we can make a little bit of a summary here. And if you'd like to read along in the box in your textbook, it's on page 101. Okay, for the definition or the little box I'm going to be talking about here. So let's say that we start out with a graph of something like this, y equals f of x, right? If we make some sort of a shift or some sort of a change in it, right? Let's say we subtract some kind of number here, right? And let's say that we have h being positive, right? H is a positive real number, right? Okay. Then what we saw on the previous page, what happened when we subtracted a number? We subtracted a positive number. We subtracted 4. Okay. Remember, that actually looked like we moved right. Okay. And that actually is what happens here. When we have this, the graph, we should say new graph, is the same shape. It's the graph of f of x, but shifted right by h units. Okay, and that's exactly what we saw here on the previous one, right? Okay, when we took and subtracted a positive number directly to that x, what we did is we shifted the graph of x squared right by 4 units right here. Yeah, so this x squared has been moved right by 4 units when we subtracted 4 directly from the x immediately. Okay, good. And we can make an alternative if we instead add when h is a positive real number. Okay, so now what we do is we say, well, the graph of this thing, new graph, is the same shape. It's going to be the graph of f of x, but we've shifted it now. But shifted, now which direction? To left by h units. Okay? Good. So an easy way to sort of remember these things is that vertical shifts and, oh, sorry, the ones we just did right here, these are called horizontal shifts, right? So these are horizontal shifts. So if I refer to what I say are horizontal shifts, that's what we're doing right here, horizontal shifts. Okay, so an easy way to make the distinction between the two is that vertical shifts are intuitive. Right? When you add a number, you move up. Plus k moves up. Minus k, you move the graph down. Okay, and alternative to that are these horizontal shifts. And remember, these are the ones that act directly on the x before any other operations get to have it, okay? And when you do a plus some kind of an h, that doesn't move right where you would think your intuition is. These are counterintuitive, right? So let me modify that and I'll write counterintuitive here because that's important. So these are counterintuitive. Okay, they're opposite what you think should happen, okay? So when you add h, it doesn't move right, it moves it left. And when you subtract h, instead of moving it left, which you would think would happen, it's counterintuitive, so it moves it right. Okay, and that's it for this video for right now. We're going to continue section 2.5 on our next day of class, which will be on Friday. But for right now, we are done with thinking about transformations. There's a few more, but we will talk more about these in class together.